Okay, starting on Unit 7, so we're talking about vectors. So, moving on to the first slide. So, vectors, if you've taken physics, or if you plan on taking physics, you will learn a lot about vectors. We have just a short, really it's just going to be this today. We're going to skip section 2 just because it's more word problems. But, so it says vectors are directed line segments represented by arrows. So, because you don't really have a geometry class, but if you did have a geometry type of class, you would have learned this is called a ray. Okay, so vectors and rays, kind of the same thing. So, but they are the directed line segments. So because they are directed line segments, that means they always go in a certain direction. Okay, so for vector notation, you will see that we're going to have, focus this. Really working? But for the vector notation, there we go. We're going to have what looks like this less than sign, but A to B. And it works just kind of like a coordinate, okay, so where it's going to be the standard position. Now, on the graph that we have there, so if this is our vector here, this is called the tail. But another way, instead of thinking about it as the tail, you're going to hear me refer to it as the initial. So that's where the vector actually starts. And then this is the head of the vector, or it can be called the terminal. So where the vector is going to end. So this would be called standard position when it's at the origin here. Okay. So there's this head minus tail rule that helps you figure out where a vector is. So on this picture up here, we have two different vectors. We have vector QR. Okay. Now, as you can see from that picture, the Q here is our tail, and our R is our head. So when you name these, so when it says QR, pretty much you're like drawing the vector on top. So there's the head of the vector, okay, or sorry, there's the tail of the vector, which starts at Q and then goes to the head of the vector. Same thing, if we want to do OP, it would look like OP with a vector on top. Okay, so in order to actually find what this vector is, you will have two ordered pairs for where Q is and where R is located. And the formula that they use there to find a vector is going to be your x value minus your x value, so x2 minus x1, and then your y2 minus y1. Okay, so now, the important thing is the y2 and the x2, those come from, so if we're looking at R here, those come from the head. So that's why it's called the head minus tail. So when we're looking at x2, so it's the head minus the tail. Okay, so for example, for the first one, so an arrow has an initial point 2, 3. So that's where it starts, and a terminal point at 7, 5. So if we wanted to just draw this, this would be our perfect graph. But the initial point down here is at 2, 3, and then the terminal point is at 7, 5. So we're trying to figure out the vector for this. Okay, so we're going to be using this head minus tail rule. Okay, or think about it as terminal minus initial. So, to find our vector here, the terminal part or the head part is at the 7, 5. So we're going to do the 7 as our x value minus our x value of 2. And then comma, then we're going to have our head value, which is 5, minus our tail value, which is 3. So my vector is 7 minus 2, so 5 would be the x-coordinate of the vector, and then 5 minus 3 is 2. So my vector would be at 5, 2, would be the vector there. Alright, so the next, vectors have both magnitude. Magnitude tells you the length or how long the vector is, and direction. Direction tells you which way that this vector is pointing. So whether it's pointing like this was in the first quadrant, it might be pointing in the second quadrant, it might be pointing down, so it tells you the direction. So whenever we're referring to the magnitude or the length, the notation for that is going to kind of look like absolute value. So when you see the absolute value bars around V, which stands for vector, we're talking about the magnitude or the length of the vector. Okay, so the magnitude formula, which is on the slide here, comes from, think about the Pythagorean Theorem. So let me draw this. So it says that coordinate is AB. So if you went to the right A spaces and went up B spaces, if you wanted to figure out how long this was, that makes a right triangle there. So if you were to do Pythagorean Theorem, A squared plus B squared equals, if I call this H squared, in order to find that H value, you would be taking the square root of A squared plus B squared. So that is the formula right there for the magnitude of a vector, and that's where it comes from. So from the Pythagorean Theorem, because a vector is just an x-coordinate and a y-coordinate, and if you were to find the length of that vector, you're essentially just finding the hypotenuse. Okay, so taking a look at the next example, we want to find the magnitudes of the vectors below. So I'm going to start with the vector PQ, and keep in mind P is where it starts, Q is where it ends, okay? Let me kind of draw this. Okay, so before we can find the magnitude, we have to actually find the vector. So in order to find the PQ vector, we need to use our head minus tail rule. So we're going to take our negative 5 and we're going to subtract negative 3 from it for your x coordinate. And then for your y coordinate, we'll be doing 2 minus 4. So my vector, this is really negative 5 plus 3, so negative 2 is going to be the vector. Okay, and that's our vector there. So if we want to find the, and I'll just call that V, if we want to find the magnitude of that vector, the formula is A squared plus B squared under the square root. So the square root, our A that they're referring to is this negative 2 squared, and then our B is this negative 2. So we're going to get the square root of 4 plus 4 to the square root of 8. So the magnitude or the length of that vector PQ is going to be the square root of 8. Okay? So then we're going to do the same thing for this other vector. And this is just called vector V. So in order to actually find the vector first, we needed to do the head minus tail rule. So we're going to do the negative 2 minus 0 and negative 2 minus 0 for the y's. So our vector is going to be negative 2, negative 2. Okay. So if we want to find the magnitude of that vector or the length, you're doing the square root of A squared plus B squared. A is referring to the x component, B is referring to the y component. So this is also going to be the square root of 8. So we're going to mention this in the next slide. But something to look at here is these have the same magnitude, which means they have the same length. So both of these vectors have the same length. Now remember, vectors have two components. They have the magnitude and they have direction. So if you look at the actual vectors here, are they pointing in the same direction? Yes. So since they have the same length and they have the same direction, we refer to these as equivalent vectors. So if you were to take this vector PQ and slide it over here on top of this vector V, they would go right on top of each other. They're the same length and they're pointing in the same direction. They're just located at a different place on the graph, which is fine. Right? So yeah, so this next part says when two vectors have the same magnitude and direction, which is what we just looked at here, same length or same magnitude means the same thing. So they are equivalent, so we can call equivalent vectors. So in this diagram, QR and OP, so QR in that picture and OP are going to be equivalent. So these are the same length and they're pointed in the same direction. So just like we saw in that example. Alright, I think I'm going to stop this video here.